For the invitation. It's been a great week in Montreal. I'm going to talk about, well, initially about the extended mind thesis, although I'll change the subject very quickly to cognition, and I'll explain why. But many of you are familiar with this. If you hadn't prior to 8 or 10 days ago, you certainly have by now. Right? The extended mind thesis is the idea that the human mind comprises materials beyond the boundary of the human organism, such things as Otto's notebook. A significant number of the everyday mental states that we attribute to each other and ourselves, beliefs, desires, hopes, fears, are constituted by, realized by, or take physical form partly in materials external to the human organism. So that's just a bit more of a gloss. And then here I wanted to emphasize the common sense mental states. Sometimes they're associated with folk psychology, the stuff we all learn as we're growing up and use to navigate our way through the world, interacting with each other. These kinds of states that we talk about, beliefs, desires, hopes, and fears. And I emphasize those because I want to contrast those with the kinds of states that cognitive scientists often talk about. And here I'll move to a discussion of extended cognition. This common sense-based understanding of the mind I think has a dubious track record. The well springs of human intelligence are better investigated scientifically. Right? So there's lots of literature on the ways in which people are wrong about their own motivation, about why they make the decisions they do, what kinds of factors in the environment they're sensitive to when they're making moral decisions, and the list goes on and on. Research over the past 50 years has been quite robust on this issue. And it's to be expected, right? Our everyday ways of understanding the world around us, the things, the theories or quasi-theories that we formulate prior to scientific investigation have turned out to be wrong time and again. Demon possession theories of disease, and the idea that the sun moves across the sky while the earth is stationary. And again, the list goes on and on of all the things we were wrong about from a kind of folk everyday standpoint. So it'd be no surprise if our normal way of thinking about the well springs of human behavior and intelligent action were wrong. Right? Maybe we've been thinking for a long time that human behavior is the output of a practical syllogism. Right? I believe that, I would desire the world to be like P. I believe that Q is the best way to bring about P, so I'm going to do Q. That makes sense, right? Yeah, but it might turn out that that's just not the structure of the process that gives rise to human behavior. In fact, I think there's lots of evidence there isn't, right? We're not just doing a bunch of practical syllogisms and acting on them, right? So, the way to figure out what's really going on, I think, is to do some science and to do some philosophical reflection on that science. So, I'm going to turn to cognitive science in this talk. I'm going to replace talk of the mind with talk about cognition as a way of indirectly exploring questions about the mind. But also I want to note that questions about the proper interpretation of theoretical trends in cognitive science are of independent interest, regardless of how you think they interface with the mind exactly. I want to just be open-minded about this stuff. It might turn out that when we do the cognitive science and we have the ultimate theory of the well springs of human intelligent behavior, there are things that look a lot like beliefs in there, right? So, maybe those folk constructs will turn out to be there. I don't know. But we have to do the investigation. Reflecting from the armchair isn't going to tell us whether they're beliefs, or if there are beliefs, what exactly they're like. Similarly for consciousness, conscious experiences. So, what happens when we do the cognitive science? Well, some people say, maybe the most prominent voice in the philosophical world here is Andy Clark, but many others have said this kind of thing, that when we do the cognitive science, we see that cognition is extended. So, in an important variety of cases, human cognitive states or processes comprise material beyond the boundary of the human organism. Now, I say important here. I include the word important because the hypothesis of extended cognition is frequently defended as a thesis about the field of cognitive science, typically in a kind of revolutionary tone or as part of a claim about paradigm shift. Right? There were all those AI theorists in the 60s and 70s, and they thought you could understand human cognition in the way they were writing chess-playing programs, and now we're going through a revolution, and it's all about bodily interaction with the world, and cognitive science is going to look all different, and right? So if that's your reason for being interested in extended cognition, this is the right sort of target, the right sort of thesis to consider. Right? Now, notice that one might reject the hypothesis of extended cognition as a thesis in the philosophical foundations of cognitive science, as a claim about the proper paradigm for cognitive science. One could reject that and at the same time accept that there are oddball cases or rare cases or occasional cases of extended cognition. Those two are consistent, at least. It's just the sort of, the thought would be, yeah, maybe you get extended cognition in unusual cases, but accepting that isn't going to change the way cognitive science is done root and branch, or isn't going to change the theoretical understanding of what's being done on the ground. All right, so I have been writing about extended cognition, I guess, for close to 15 years now. There is a lively debate about this topic. I have tended to be skeptical. I don't dismiss the idea offhand. I think we do need to look at the science and try to do some theoretical interpretation of that. Right? But I've tended to be on the skeptical side. Right? And so this is why I talk about a roadmap to resolution, possible resolution, because I'm thinking about a debate here that the proponents of the extended view, and then there are some voices in the wild saying, no, 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 slow down. Right? How could we resolve this debate? Is it just the revolutionaries versus the conservatives, and it's just a sort of personality trait or psychological tendency to be on one side or the other? Is there any way to sort of work this out? Right? Well, I think we're going to work it out by trying as best we can to develop a theory of cognition that's sensitive to the successes we've had in cognitive science so far. Right? This is all going to be tentative, nothing definitive or final. Right? Yeah. And I think we want a theory of cognition for more than one reason. Here are a few. It's a way to give content to claims about cognitive extension. If somebody says, there's this thing, cognition, and you find it in unsurprising places, well, you might want to know what they're talking about. What is this stuff that you find in surprising places, right? So I think it's kind of important that people say what cognition is. Right? So that's one reason to want a theory of cognition. It also may, going back to some of the things I said when I first put the label of the slide up, the title up, it may provide a way to adjudicate debates about the extended view. And it's a way of addressing just a question of independent interest about the nature of cognition, and perhaps indirectly about the mind. Folks have been interested in cognition for quite some time. The last 50 years, you have had people writing about rules and representation-based approaches and connectionist networks and how many representations are in connectionist networks and whether that's just an implementation of cognition and blah, blah, debate. People who weren't particularly talking about the extended view. There's lots of reason to be interested in the nature of cognition, whether or not you find the debate about extended mind or extended cognition compelling. All right, so a little bit of a digression here for a minute to issue a caveat. A theory of cognition is often equated with something called a mark of the cognitive. It's a phrase that sometimes gets used. It goes back to an earlier term, the mark of the mental. I think that maybe Hoagland might have introduced, doesn't matter. And this can sometimes be confusing because we're talking about cognitive science, and I think people have sometimes misunderstood the point here and thought that the people discussing theories of cognition thought that cognitive scientists had to have a theory in order to do cognitive science. And that's not at all what I'm on about, right? Cognitive scientists need not have in hand a deep or substantive theory of cognition in order to do cognitive science, right? You just take some data, right? There's this really impressive stuff people do. They have conversations. And they devise scientific theories, and they write books, and they build buildings, and they create artworks, and wow, there's all this really cool stuff people do. Let's try to figure out what it is. Let's collect some data. Let's model the data. Do you need a theory? No. You might start to recognize patterns in the data. You think, something that's really interesting about these various forms of behavior is that there's a kind of flexibility to them, right? People who are working on a project gets disrupted in some way, seem to be able to correct and finish the project anyway, right? And so, there are patterns like this you might think are interesting, and cognitive scientists might then take those patterns themselves to be an object of inquiry. How do we understand the flexibility part? Let's focus on the flexibility part, right? But none of that requires having a theory of cognition prior to the doing of cognitive science or in the doing of cognitive science. Where you need a theory of cognition may be when you start doing philosophy of cognitive science, or philosophical foundations of cognitive science. Arguments about the best theoretical interpretation of cognitive scientific results may need to appeal to a theory of cognition for the kinds of reasons I had on the previous slide. Right? Some people say we're seeing a paradigm shift in cognitive science. The working cognitive scientist might say, paradigm shift? I don't care about paradigm shift. I like connectionist models, and I've got an artificial neural network I built, and look, I can model some data. What about paradigms, right? So they might not need to think about this stuff to do really good work. But if you're trying to understand broader trends in cognitive scientific work, you may want a theory of cognition. But that's one place where it comes in, right? Not as a prerequisite for doing the science. Okay, so what's the nature of the problem then? The problem that I'm going to talk about for most of the rest of the talk. Well, it's an important point. Virtually everyone agrees that many external factors contribute causally to the production of intelligent behavior. All this kind of data that we begin the scientific inquiry with that I listed earlier. I listed some examples of them. Right? Similarly for historical contributors. And virtually everyone agrees that not all of the contributors count as cognitive. There's all kinds of stuff that in a more proximal or more distal way causally contributes to the production of behavior. And nobody, not even the people in the 60s and 70s who were writing chess-playing programs, denied this. Right? People, when they were young, depended on their parents for sustenance. And if they hadn't depended on their parents, they wouldn't have learned to play chess. And there wouldn't have been chess-playing skills. Right? Nobody denies any of that. Right? So there's not really, I think, sort of emphasizing the extent to which individual development is affected by cultural surroundings, emphasizing the way in which our cognitive skills are dependent on the way we learned to handle problems that we face. Right? I don't think this is going to really help to resolve the debate at all. Everybody agrees that this stuff is important. Right? The question is about, as I put it in an early paper, is about the difference between an extended view of cognition and an embedded view of cognition. Do we take all of those causes and say, you know, they're all part of cognition, right? My parents taught me something, so they're part of my cognition. I don't know, you could say that if you want, right? The sun helps me to navigate the environment, so the sun's part of my cognition. Yes, you could say that if you want, right? But I want some motivation, right? What you could do instead is say, yeah, all those things are really important, but what you've got is a sub-portion of those causes that have a special status. Now, I've really been talking about the first sentence there. Everybody, you know, agrees that there's lots of causal contributors to the production of intelligent behavior, and I also included historical contributors. What about this part? Virtually everyone agrees that not all of the contributors count as cognitive. I think that's right. At least some really important contributors to the debate, proponents of the extended view in particular, have resisted including everything that contributes to the production of your behavior in the cognitive system or as part of cognition, right? I mean, there's a sense in which Aristotle contributes to my behavior, Aristotle, the ancient Greek philosopher, because I read Aristotle's work and I say stuff about it, and it wouldn't be here now if he hadn't existed 2,500 years ago, roughly. Right? So, you know, we don't want to include Aristotle as part of my cognitive system or one of the cognitive productions, contributors to my behavior. Right? So I think everybody wants some way to differentiate between the causal contributors that are genuinely cognitive and the other causal contributors. Right? So the question then becomes how to separate on a principled basis the causal factors into two groups. Can we find in successful work in cognitive science a distinction of central importance that does the job? Is there any hope of kind of looking at wide swaths of work in cognitive science and saying, look, this distinction keeps popping up over and over again, right? There's the separation of the causal contributors into these two groups. Whether they're called cognitive and non-cognitive doesn't matter. The question is whether, from a philosophical standpoint, when we stand back and we look at all this work, we see some kind of principled distinction showing up in all of the different kinds of approaches, say, different successful research programs. So I am going to argue that the distinction here is the distinction between the cognitive system proper and the stuff beyond the cognitive system. I'll say a lot more about cognitive systems as we go along, but here are some initial observations. So in the first paper I wrote about this topic, I talked lots about some of the arguments Clark and Chalmers had given, some of the stuff Mark Rowlands had said. You know, I basically tried to show that the arguments they had given for having extended kinds in cognitive science weren't compelling, right? Or at least led us to a standstill. And in the final section, the denouement, I said, the priority of cognitive systems, that's what it's all about, right? We have to figure out where the cognitive system stops, and all of the scaffolding, the rich inputs, the props, the supports, the tools lie, right? Where that boundary is. So in this final section, pointed out the cognitive science seems to investigate the cognitive or mental capacities of integrated cognitive agents or thinking subjects. And the thought was that if we could identify those things, then we'd find the boundary between the causal contributors that are cognitive and the ones that aren't. And the capacities of these things are the things that give rise to intelligent behavior, along with the other contributors. Yeah, the point of that bit is just to remind us of the anchor, the explanatory anchor, or the data that we want to ultimately be responsive to is the observable behavior. Right? So it's not the capacities in and of themselves that we're trying to explain. So in experimental practice, this is part of what motivated me and impressed me in that paper, is that in experimental practice, persisting systems sort of move from one setup to another. The results across conditions and experiments reveal features of those systems or the principles by which they operate. So think about this from the other side, the engineering side. One of the examples I gave was the example of creating artificial intelligence that diagnoses diseases. What we want is a stable unit. It can be moved around, but a sort of unit that is integrated and persists through time as a single system to which you can present patient after patient or case description after case description. Right? Patient comes up, little diagnostic tool says, you've got rabies. Patient's taken away. Right? Patient comes up, diagnostic tool says, you've got lupus. Right? And you're taken away. Right? So, you know, it might be that the diagnostic system is sensitive to all kinds of sort of micro features of the patient. There might be exploratory things that the diagnostic system does if it's able to send out like complex probing sensory signals. And there's all kinds of stuff that might involve interaction between those two things. But then the patient, one of the two things, leaves, right? And the diagnosis is spit out. Right? And that's the kind of distinction I think that was really, that really made an impression on me at that point. So, but it was all sort of inchoate then. I said the kind of thing I said in the last slide that didn't give a theory of cognition. I'm still not going to give you a full theory of cognition, but gets close anyway. So what is cognition? I claim that a state is cognitive only if it's the state of a component of a cognitive system where that is a persisting collection of mechanisms that co-contribute in overlapping subsets to the production of a variety of forms of intelligent behavior.
Component?
Component?
Yes, what is a component?
This can just be thought of as physically localizable. Right? So where do we get this? Is a state of a component. Oh, that's mechanisms or components. Right? So you can think about this just in terms of physically interesting parts. Right? So both sides on the debate are talking about various things that contribute to the production of intelligent behavior. So it could be ambient light in the environment. It could be text on a page. It could be the activation of this cluster of neurons that co-fire at an elevated rate together, higher than chance, right? Give, you know, some theory of mechanisms. It's going to have to be pretty broad to satisfy people on all sides. But my point is, line up all those mechanisms, all the ones that contribute. And then you'll separate them into two groups. The ones that are part of this collection, the persisting collection of these mechanisms that co-contribute in overlapping subsets to the production of a variety of forms of intelligent behavior. And then the rest of them will be more like one-offs or specialized tools that are only useful in a limited range of contexts, things that you use sometimes and other times you don't. Yeah, so you'll find a lot of diversity among the outgroup mechanisms, right? but the way you'll stick them in the outgroup is by seeing that they don't fall into this persisting cluster of cooperating mechanisms. This, as I've written it, states a necessary condition. So it allows that further conditions might be relevant. Right? Stating it as a necessary condition is, just fine, I guess, if the point is to prove that certain things aren't cognitive. If what I'm out to do is show that some of that external stuff is mere scaffolding, not genuinely cognitive. Right? If that's what I'm out to do, then just showing that it fails to meet a necessary condition is good enough. Right? But if we wanted a full theory of cognition, we might have to add some other stuff. I'm going to say more as we go along about what constitutes an integrated system, one of these persisting systems. I'll give you a more formal measure of what it is. So that will give you more idea what I have in mind when I talk about, a collection of a collection of mechanisms that co-contribute, these overlapping subsets. I'll tell you more about that, but I won't say much more about what the added juice might be, right? The extra magic, right? It could be that these states are representational. So in addition to being the state of a mechanism that has this privileged role in the cluster, right? Maybe it has to be representational as well. I don't know. I'm not wedded to that, right? Maybe it has to have come to be part of the system in a certain way. That is, there's a developmental criterion. I'm more sympathetic to that. I think that the way cognitive systems come to be integrated is part of a rich and interesting story and helps to explain lots of the characteristics that they have now and the ways in which the individual interacts with the environment now. So I think the history of the shaping up of cognitive systems is like an important aspect of study in its own right. And differences between the way these clusters of mechanisms shape up and the kind of profiles of the various other mechanisms that aren't part of the cluster, these differences will be important, right? Developmental, historical differences. Now, why would I say that? Look at this slide. Is there any argument up there? No. I said, what is cognition? And I said, here's what cognition is, right? Why should you believe me? Let's start with the idea of models and modeling. Right? So modeling is perhaps the most commonly used tool in the sciences. It's arguable that it's the fundamental tool in natural sciences and those that have a similar sort of rigor. Social sciences, computer science, right? What is a model? Well, at the most abstract level of description, a model comprises abstract entities, or maybe symbolic specifications if you don't like thinking about abstract entities, and their properties, and specifies relations they bear to each other. Right? So a model of a system of gases says they're elements. Right? What are those elements of this certain kind? When you specify the model, they're either just inscriptions or they're abstract entities that you're pointing to with the inscriptions. Right? And then when you use that model to explain the behavior of a gaseous system, you map those elements onto elements in the system, right? In the actual system, the target system. And then you have equations that are part of the model. And the behavior of the abstract elements over time, which is just one more abstract parameter in the model, right? The behavior of the elements over time is in keeping with these equations. And so you expect the elements of the target system, the real molecules or atoms of gas, you expect their distribution to obey the equation. Just run the model for 10 seconds, and the atoms' locations in this abstract space will have changed. The real atoms that those are mapped onto will have changed accordingly if it's a really good model. Of course, there's always some error. Right? All right, well, that was a quick sort of primer on modeling. Successful modeling predicts or explains behavior of a target system on the assumption that the system has concrete parts with properties related to each other in the ways in which the elements in the model relate to each other. And these relations are typically time indexed. They talk about what happens over time. So either differential equations or some kind of difference equation may be used to specify these computational operations. What I claim, and now here you're getting something that looks more like an argument for the view of cognition that I proposed. What I claim is that cognitive modeling has a common thread. all successful forms of modeling, whether it's computational or connectionist or subsumption-based or dynamical systems-based or sort of brute neural, right, posit a set of persisting elements and their interactions that, as a whole, that set governs the production of intelligent behavior, partly by managing responses to the stream of changing environmental conditions. Right. So part of what I'm doing is developing what's sometimes called an embedded view. That's what I've, in the initial article, called an embedded view, in contrast to an extended view. You've got lots of interaction with the environment. You can model those kinds of processes where the agent or subject is interacting in a dense, ongoing way with the environment. But there'll be one portion of the model, and the way I just put it, of course, implies what I think, which is that this portion of the model is going to map onto stuff inside the organism. Not a given, though. But you've got, if you're trying to associate this with a common sense picture, or kind of an image that you can, I don't know, put some meat on, right? Make some sense to you. Think about it that way. Think about the model as having these different elements. Part of the model is made up of these persisting elements that are interconnected. And then you've got you might think of as values in the particular model or the particular running of the model that correspond to stimuli. Things that are in the passing parade of stimuli that humans are exposed to. Right? For now, I just want to convince you that this is a common thread that runs through all these kinds of modeling. That you've got a distinction between something like the fleeting components in the running of the model and the sort of architecture, as it's sometimes called, especially in the computational tradition, but elsewhere as well. I like this approach because it's ecumenical in many respects. Right? There's nothing about, we know cognition proceeds by rules and representations. I don't know if it proceeds by rules and representations. It's just the sort of jury's out, I think, right? There's lots of stuff a rules and representations-based view can do, but you're going to beg the question against a lot of the proponents of the extended view if you rely heavily on that. Right? So what I prefer to do is take this kind of more ecumenical stance and look at a wide range of modeling practices that have been successful, at least some research programs, and see if there's something common. And it's this distinction between the persisting architecture and the passing parade of stuff. Right? All right, so call this posit an architecture. I claim it's the central theoretical construct of cognitive science. The importance of that is that even if you aren't really excited about the label cognition or aren't looking for the use of that term specifically in the publications of cognitive scientists in this regard, I'm claiming that this is the way to resolve the debate about extended cognition. You say, let's find a central theoretical principle that divides the causal contributors into two categories. Right? And I'm saying you get this in the models. And further claim, it would seem to appear in most human cases within the boundary of the organism. That's a bit I'll have to argue for more. All right, so this all can be sort of parlayed into an argument against the extended view. Successful cognitive modeling of all cognitive scientific stripes proceeds by the positing of a relatively persisting integrated architecture, thereby dividing the elements of the model into two categories. Maybe on the outgroup side, there's more than two. Right? There's also background conditions or something like that. Premise two, there's no other clear and plausible distinction between what's distinctively cognitive and what merely causally contributes to the production of intelligent behavior. People have tried lots of other things. This was not meant to be too much of a negative talk, so I'm not going through, Clark says this one time, and he says this one time, and Mark says this, and somebody else says that, and they're all wrong, and here's why, one after another. I've done that kind of thing. I won't do it here. So intermediate conclusion, being a state of some mechanism or component of the architecture is a necessary condition for being cognitive. Right? And that's the sort of view I expressed earlier. Now, where does that take us? Farther? As a contingent matter of fact, such architectures are, for most humans, most of the time, housed inside the organism. Conclusion, therefore, cognition isn't typically extended. Right? So I wish it were this tidy. Right? So one of the sort of complications that arises is that models will often be given at different levels of abstraction. And so you might have a model that maybe focuses a lot accounts for the fine-grained interactions at the interface between a persisting architecture and what we would call the stimuli, right? But you might have a sort of less fine-grained model that can just sort of treat the subject organism, I should say, together with some external thing as a single unit, right? Maybe you're modeling what I'm doing right now, and there's no point in differentiating between my hand and the remote control, right? Including that articulation in your model doesn't do any good, right? So what do we say in cases like that, where some models are more articulated than others? This is where maybe philosophers come in. We talk about what the metaphysical interpretation of that situation should be, what the proper metaphysical interpretation is. Does one model trump another? Is there a kind of counting up of models? Does the more finely grained model always win, right, when it comes to deriving ontological morals? I don't know. But let's go on after that. Here's an argument that I put it here as an argument for premise 3. What was premise 3? That was the one that said it's a contingent matter of fact. These architectures are, for the most part, inside the organism. Right? But this is not just an argument for premise 3. You can think of it as a kind of independent argument for putting cognitive systems inside the human organism. You could just, trash all that stuff about modeling for right now. Just forget about modeling and go this way independently. So, second sort of semi-formalized argument. Cognitive science has had enormous success by treating individual organisms as a loci of persisting cognitive systems. Well, we'll just leave it there. I'll come back and say more about that in a minute. The best explanation of this success is that there is at least one bodily bound cognitive system, right? If I were to say to a proponent of the extended view that cognitive science has, over the last 50 years, had enormous success by treating individual organisms as a loci of persisting cognitive systems, right? And therefore all of the cognitive systems are inside the organism, I would get laughed out of the room, right? And that is how people have occasionally interpreted this stuff. But no, right? Of course I realize that what they're saying is we're being radical. We're proposing that cognitive science up to this point hasn't been doing things right. So to say cognitive science has been doing things one way, and therefore we should keep doing it that way, is just to kind of gainsay what the proponents of the extended view are saying, right? They're saying it's time to change, right? So I want to give them a principled reason not to change so much, right? And that involves not limiting cognitive systems to the success that's been had so far, what seems to be driving the success that's been had so far. But it involves starting, at least at the outset, by taking that success seriously and giving our best explanation of it. And I think the best explanation is that there's at least one cognitive system that's inside the boundaries of the organism. Right? Now, here's where things get a little tricky. I think extant work in cognitive science is meant to bolster Heck, recreates this structure. At least when the models are more articulated. Right? You might think that when you're solving the, word problem in a Scrabble game, become coupled to the tiles on your Scrabble rack, and you're shifting them around, and you're looking back and forth, and you're shifting, and you're looking back and forth, all sorts of stuff is happening, right? If you give an extended model of that, what do you have to include in that model? Well, my claim is you have to include all the standard activities of the organismically bounded cognitive system and the details of the interaction with the Scrabble tiles and the sensory signals, the tactile signals. And my point is everybody's got to include that in their model. So here we have a model that I like, right? You've got an organismically internal system. You've got interactions with the environment. Behavior is produced. I found a word, somnambulistic. No, that has too many letters. I couldn't. Well, maybe there's already some on the board, right? So I come up with this great word, and I play it, right? And the model says that behavior was produced by the interaction between the organismically housed cognitive system and all this stuff that's happening at the periphery and in the world, right? So I've got a cognitive system and stuff beyond the cognitive system, right? And the proponent of the extended view has to have all that detail in there if they're going to get the answers right, if they're going to account for the data. And then what they do is say, oh, and besides, there's another cognitive system, or there's more cognition outside, right? And it's just sort of gratuitous. I mean, you can call it that, but it seems to me employing the kind of methodological principles that tend to rule in the sciences, simplicity-based reasoning, for example. It's just gratuitous to add a further cognitive system. Oh, and there's a bigger one that also includes the stuff beyond this. So that's the next premise. That introduction of cognitive systems that span body and world is thus gratuitous, given that the proponent of the extended view has to pack in all the details that the proponent of the embedded view, my view, has packed in. Adding another cognitive system is gratuitous. All the causal explanatory work can be done by the existence of the bodily bound cognitive system and the ways in which it manages interactions with the environment. Thus, the one and only cognitive system of theoretical import appears this time to be mostly in the body. Thus, there's no current reason to accept Hegg. All right, so why do I think there's been this success? I mean, this is another, I think, dialectically important point. Many proponents of the extended view, not all of them, but many of them will start off their books saying how, what a wreck cognitive science is in. I said that right. Right? The computational paradigm will never work because there's a representational bottleneck, and this explains the frame problem, and, you'll never get anywhere. We need a new approach. Right? So, it's kind of, might sound a little bit like I'm begging the question if I just say cognitive science has been really successful treating the organism as the locus of a cognitive system. But there's loads of work in cognitive science that's been, successful research programs. I'll give you a couple examples that have produced robust results across a variety of experimental conditions and experimental setups. Right? This best work models multiple tasks as the products of the activity of the same body-bound system. So here's a kind of example. This is, I don't give a citation, but it's inspired by some work by Lovett, Daly, and Reeder using John Anderson's ACT-R model architecture. Differences in the value of a single parameter within an otherwise stable architecture these differences explain individual differences in performance on various memory tasks. So they have people perform one memory task, an n back task, or you're supposed to remember like 3 back. What was the third to the last thing you saw, right? As a stream of digits or something goes past, right? You model that, right? You model the behavior of the various subjects, and then you use the parameter value that was necessary to get a nice clean fit to the model, right? Nice fit to the model. You use that parameter value to predict those subjects' performance on a different task, like a digit span task. They use a modified digit task. The method's pretty complicated, but not much. Right? And the outcome was really good. Right? That is, the fit was excellent. The predictions were verified. So you get lots of things like that. Individual differences in comprehension of narratives across material types. So I think much of this work was done by Morton Gernsbacher and her colleagues at Wisconsin, showing that you can account for individual differences. Let's put it this way. Just that there's a correlation between individual skills in constructing narratives. And by that, I'm not articulating this very well. The point is, your ability to handle a narrative in one medium correlates with your ability to handle it in other mediums. So whether you're watching a movie, or whether you're reading a story, or whether you're hearing somebody tell you a story, right? Your ability to respond to questions afterwards, right? To construct a coherent narrative from that was presented to you in that medium correlates across medium, and it varies from one individual to the next, right? So there's something like a more abstract skill that is housed in the organism, the skill of constructing narratives. Why do I say it's housed in the organism? Because the materials you're interacting with are different on different cases. The one time you watch the film, and another time you read the book. The book's not there when you're watching the film's not there when you're watching the book. Right? So the system, whose properties have been uncovered by these different experimental conditions, is a system that seems to be housed in the organism. Similarly, for say the role of frontal parietal circuits in attention, you see this across a wide variety of tasks. Effects of certain lesions, like in visual neglect, say, across a wide variety of task types. one where the differences in materials used is really emphasized is in some of these developmental results on false belief tasks. You know, when you get kids of a certain age to try to attribute a false belief to a character in a story, they make certain kinds of mistakes at certain ages. We won't go through the details. And then certain age, they start to pull out of it, right? You get similar results whether you use finger puppets or whether you tell stories or whether you use, I think Wimmer and Perner originally used some little Velcro-backed cutouts that were attached to a board and moved around. So it doesn't matter what materials you use. The kid before about age 4 isn't very good at attributing false beliefs and predicting behavior on the basis of it, right? And then they come to get better at it, right? And the developmental trajectory is similar regardless of what materials you use, right? Same kind of logic applies here as I applied when I was talking about the ability to construct narratives. It can't be that it's the child plus the storyboard whose skills are being understood, because when you expose the child to a false belief story using puppets, the storyboard's not there anymore. When you expose the kid to a false belief stimulus, right, just by reading a story, right, there are no puppets and there's no storyboard. Right? And so it's a stable, relatively stable trait of the system that's inside the organism that's being probed across these various conditions. Now, it didn't have to turn out this way. There didn't have to be success here. If the true cognitive system included external materials, and cognitive scientists had spent 30 or 40 years just taking organisms and moving them around from condition to condition, they would have been really frustrated. They would have not gotten nice results, robust results from a variety of research programs, because they would have been leaving out part of the cognitive system all the time. And it seems likely anyway. So they took a guess at the grain of at least one cognitive system, and they seem to have gotten it right, because they got lots of good results. That's how science works. You know, we were talking about this earlier with regard to representation. I don't know what representation is, but a way to understand, to try to figure out what it is to posit a representation relation and then see how much causal explanatory mileage you get out of it, right? A represents B if and only if this fancy pattern of causal interaction holds, right? And then, you know, do a bunch of cognitive science that's predicated on that. See what happens. Right? All right, so I haven't told you much about integrated cognitive systems, what makes them integrated. I don't have a whole lot more to say beyond this. This is a bit challenging, so I guess I'll run through this and then leave it there. What's up? Question? Thought? 1 minute. Okay. So it's 45. Do we want to leave 15 for questions? Yeah. Okay. Okay. How much time do we want for questions? 15. Okay. That's what I was. Okay. Good. So here's the idea quickly, and I'll stop. The idea is to give some sense of what makes these systems integrated. Maybe this doesn't appear in the models. Maybe this is an attempt to sort of understand from a different angle what it is for this system to be, for a system to be an integrated system. Yeah, so I'm just going to lay it out here. Here's the following procedure. For any subject at any time, form each non-singleton subset of mechanisms that have distinctively causally contributed to the production of any form of intelligent behavior. Right? So it's just like a historical thing. The subject has, if you had a catalog of everything they've ever done, what are all the mechanisms that produce that? Right? So form each non-singleton subset of all those mechanisms. And then for each of these subsets, relative to each form of intelligent behavior, there is, for each of its proper subsets, a probability of its being a causal contributor to the production of that form of behavior conditional on the complement of that set's being a contributor. So take something like word form recognition mechanism, right? Face recognition mechanism. You know, take a few mechanisms and say, what's the conditional probability, the following probability, of the use of the face recognition mechanism conditional on the contribution of the word form recognition mechanism, right? So this is a measure of likelihood of co-contribution. This is a way of measuring that, right? Now rank order these conditional probabilities. So we get a whole bunch of these subsets. The point is the mechanisms that co-contribute together with lots of other things, a variety of other, you know, co-contributors to a wide variety of intelligent behavior, right? Those things will show up in at least one of these high conditional probabilities, maybe lots of them. Right? Rank order these conditional probabilities, take a natural cutoff, higher probabilities in the lower ones. If integration is a natural kind, there should be a statistically significant gap. For each mechanism appearing on the list of sets with higher conditional probabilities, count the number of times it appears, and then rank order mechanisms accordingly. Right? So if you use your visual, let's call it shape recognition mechanism, together with lots of different subsets on different occasions, then this thing is going to appear lots of times on the list of sets that have internally high conditional probabilities. And that will make it part of the cognitive system. Right? Statistically significant gap separates those mechanisms that appear frequently on a set from those that don't. This is a thought, then. The integrated system comprises all and only those mechanisms, the sum scores of which appear above this gap. The ones that appear a lot on the list of sets with high conditional probabilities. Those are the ones that are part of your cognitive system. There are other ways to measure it. I'd love to hear, if somebody has alternative proposals. I think maybe people who work on web stuff might think there's something relevant here. But I should leave it there. I'm out of time. Thanks.
Thank you for the interesting insights. We have time for questions.
Oh, yes, I'm interested in whether or not you think that extended cognition